Welcome to Further Solutions Academy. Please do well to share and subscribe to our YouTube channel. Then also you can reach us via chat, call on +234 80 95990. You can either call us or you can leave us a message on WhatsApp or reach us out on Telegram. You can reach us through this number. So this is Further Solutions Academy. Once again, please do well to share and subscribe to our YouTube channel. So today we will be having a lecture on a very basic aspect of chemistry. Nevertheless, a part that needs to be evaluated, that needs to be examined. And one of those parts is known as balancing chemical equations. Balancing chemical equations. This is a very basic aspect of chemistry, but yet we need to understand it very well, because we realize that some have issues with balancing chemical equations, especially at the high school level. So before we talk about balancing chemical equation, what is a chemical equation? A chemical equation is a representation of the process or processes involved in a chemical reaction. A chemical equation is a representation of the process or processes involved in a chemical reaction, based on the fact that some chemical reactions have more than one process. So if you show this process in a representative manner, you are writing a chemical equation. And chemical equations they have two sides. We have the side A to side B. There's always an arrow that shows a chemical equation. There are different kinds of chemical equation. There's a reversible and there's irreversible. This kind of reaction is irreversible, where we just have the arrow going forward. But in case of equilibrium and so on and so forth, we can also have this kind of equation. Either one, they are all chemical equations, in as much as we have something going towards something. And every chemical equation you see comprises of two different sides, which is the reactant side and the product side. We have the reactant side and the product side. Please take note of something. Anytime you see a reaction or an equation rather, even if you have just one product and if you have one reactant and many products, no matter the number of products or the number of reactants, whatever, if you are looking at it through this way, whatever is on your left hand side is definitely the reactant, and whatever is on your right hand side is definitely the product. Some people think, oh, the product must be more than the reactant. Like for instance, in the decomposition of N2O4 to give about two different products, some people think, oh, N2O4 has to be the product. No, it can also be the reactant. Some bigger molecules decompose to give smaller molecules. It doesn't change them from being the reactant. So that is that on this. So the next thing we should just go further, I think we should just start or go straight to the business, which is balancing chemical equation. Let's say we'll be starting from the basics. So please do well to follow me through this. So we'll be having an equation. Let's say we have an equation Al plus O2 to give you Al2O3. Like I said, if you follow what I said earlier, the reactants are this and this is the product. Now, the first thing you should check in a chemical equation are the element atom count. Now, I have aluminium, I have oxygen. I have aluminium and I have oxygen, meaning every element that is present on my reactant side must definitely showcase in my product side. And the concept of balancing chemical equation I would like to present to you is like a case of a seesaw, or a weighing balance. So when you look at a seesaw, you realize that it is expedient that what the weight on this side is equal to the weight on this side. Okay, maybe I should represent this. This is the concept of balancing chemical equations. So let's say we have our reactant here, and we have our product here. This is a balanced reaction. Why? Because the same number of atom count we have in the reactant is the same number of atom count that we have in the product side. This is a balanced equation. So it means when you look at your equation, you should be able to look at the atom count, and this will give you a glimpse of whether it is balanced or not. Let's look at the reactant side. In aluminium here, how many atoms of aluminium do we have? 1. Oxygen here, how many atoms of oxygen do we have? 2. In the product here, how many atoms of aluminium do we have? 2. How many atoms of oxygen do we have? 3. You see that it is not balanced. The number of moles of oxygen here is not equal to the number of moles of oxygen here. The number of moles of aluminium here is not equal to the number of moles of aluminium here. So definitely something needs to happen. So when you are balancing a chemical equation, the right way to do that is by placing coefficients as number of moles beside the compound or element. But please do not make the mistake of writing something else, like something of this sort. No, you are not making aluminium 2 by putting it here. The way to balance, that is one mistake students make. When they try to balance, they say, okay, aluminium is 2 here, and suddenly they just place 2 here and say oxygen is 3, so that means this is 3. That is a very wrong step. The best way to balance is by placing molecular coefficients beside the atoms or the compounds involved. Excuse me, beside the atoms of the atoms or the compound involved. Do you get it? So how do we do that? Now let's start with aluminium. Please, it is advisable that you can start. It is advisable that you can start with the elements that you see first. With the elements that you can see first. I can see aluminium first, and aluminium here is not balanced. So what do? I can just place 2 here because I have 2. So because I have placed 2 here, automatically I don't have 1 mole of aluminium again. I have 2 moles of aluminium. Aluminium is now 2 and 2 because why? I have placed the coefficient in front of aluminium. But unfortunately, oxygen is not still balanced. And how do I make oxygen balanced? In a way to make oxygen balanced, I could put 1.5 here. I could put 1.5 here. And if I put 1.5 here, it means 2 molecules of oxygen in 1.5 moles. That will give us 3. But this is, according to chemistry, this is not permitted in a way. This is not permitted in a way, except under some conditions. So I cannot just, the uncomfortability of having a fraction or a decimal, it would not be nice. So what do? The best thing to do is to realize that, oh, I have 2 molecules of oxygen. So if I put 1.5 here, definitely this already becomes 3. So how can I make this a whole number that can balance up oxygen without having a fraction here? And the best way to do that is to multiply through. From our basic mathematics, you understand what it means by multiplying both sides, both the reactants and the product side. So I want to multiply through by 2. I'm multiplying all of this by 2 to see whether I can now have a balanced form. If I multiply all through by 2, this times 2 give me what? 4 molecules of aluminium, right? Plus this, because I want to eliminate this decimal. So that becomes what? 3 molecules of oxygen, right? Then my product side, I'm multiplying by 2 means I'm placing 2 as a molecular coefficient. Please take note of that. So placing 2 as a molecular coefficient, I have this as my product. Let's take atom count again and see whether it is balanced. How many moles of aluminium do we have here? we have 4. How many moles of oxygen do we have here? We have 2 molecules of oxygen in 3 moles. That is making them what? 6. Then in this place, I have 2 moles of aluminium, but this coefficient, okay, please take note once again. When you have a coefficient in front of a compound, let's say you have something like of this sort, 2NaCl. This means that you have what? 2 moles of sodium and 2 moles of chlorine atoms. It is not just for sodium, it is for sodium and chlorine atom. So if you have learnt what I just said, so definitely these 2 covers for the whole of the compound. So this is, and I already have 2 moles of aluminium. So summarily, in a summative way, I have what? How many moles of aluminium here? I have 4, which is 2 times 2, just like we did here. Then for oxygen, I have 3 molecules of aluminium in 2 moles, because this 2 applies to it also. That is 6. So how do I check my atom count? Aluminium 4, for oxygen 6, and for oxygen here 6. So equation is balanced. I hope we understand that. Let's just pick another equation and let's see how we can do that better. So let's have an equation of something of this sort, where we have C2H4 gas plus O2 gas to give us CO2 gas plus H2O. Now, this is, okay, I think H2O is gas here also. So if we are looking at this kind of equation, please, I will advise that you solve for the elements that are together before you come to individual elements. Please take notes so that you don't miss your step. You try to solve for the element that are together before you come to individual element. So if I have something like this, let's first take the atomic count and see. Carbon, here I have how many? 2. Hydrogen, I have 4. Here I have 2. Here I have 1 carbon, 2 oxygen. Here I have 2 hydrogen and 1 oxygen. Carbon is 2 here, carbon is 1 here. It's not balanced. Hydrogen is 4 here, hydrogen is 2 here. It's not balanced. Oxygen is 2 here, but oxygen is 2 plus 1. That's another thing. Please, when you are taking your atom count for a compound like this, where you have your elements or your atom in 2 different compounds, please use the plus sign when adding them together. So for oxygen, generally, I have 2 here and I have 1 here. That means for the product side, I have 3 moles of oxygen, and for my reactant side, I have just 2 moles. I have just 2 moles. So now, let's start the balancing. Let's start with what we can see first. We can see our carbon. So let's say we are starting with carbon. Carbon is 2 here and is here 1 here. Please, when you see a higher number on one side and a lesser number, try to add to the lesser number. Just leave the higher number and go to adding the lesser number. So here I have 2. So let's just say I want to change this. Please don't make the mistake of putting this. This is a blunder in chemistry. It's, in fact, it's an anomaly. It's not right at all. So what do? For me to put this, let me say I'm putting 2 as a coefficient here. That means automatically carbon is 2. But something has been tampered with here. Remember what I said earlier, this 2 does not belong to carbon any longer. It affects oxygen also. And because it affects oxygen also, so oxygen has what? It's no more 2. Oxygen has 4 moles. Are you getting it? So oxygen has 4 moles. We will come back to oxygen. Like I said, deal with all the atoms in the combined state before you come to those in the individual state. So now let's come to hydrogen. Hydrogen has 4 here, right? And in this place, hydrogen has 2. I said you go to the one with the lesser count. So if I want to make 2 4, the best way to do that by multiple is by what? Placing a 2 here. Now when I place a 2 here, I have hydrogen is no longer 2. Hydrogen becomes 4, which means hydrogen is balanced. Yay, hydrogen is balanced. But something is wrong. Something is wrong. Because why? This 2 doesn't affect just hydrogen. It affects oxygen also. So in this place, oxygen is no more 1. Oxygen is carrying a coefficient of 2 molecularly. So it now becomes what? 2. Now that this has happened, we can now come to the oxygen. So we have our carbon balance, we have our carbon balance, we have our hydrogen balance. For our oxygen, we realize that, okay, 2 carbon, 4 hydrogen, 4 hydrogen. But for our oxygen, we realize that in this place, how many moles of oxygen do we now have? We have 4 plus 2, which is what? 6. Remember I told you when you have an additional sign, you don't multiply them. After sorting from one compound, you add it to the other compound. So we have what? We have 6 moles of oxygen there. So here we have just 2. How do we make these 2? 6 multiple. And how do we make multiple? 2 to 6, we multiply by 3. And how do we do that? Is by placing 3 as a coefficient here. So when we place 3 as a coefficient here, we have oxygen, 2 molecules of oxygen in 3 places. So that becomes what? 6. Then summarily, oxygen on the reactant side, we have 6, and on the product side, we have 4 plus 2, which is what? Equals to 6. Do you get that? So we have balanced this equation. We have balanced this equation. Now, let me show you something about the visual representation of what we have done. The visual representation of what we have done, let me show you to you. Drawing the structures. This is 18 in organic chemistry, and we have, this is the structure. I want to use this to explain some blunder to you. So, for oxygen, we have, this is oxygen. For CO2, this is the way to draw CO2 molecule. For H2O, this is the way to draw H2O. Okay, now we have balanced it earlier on, but I want us to use this visual representation to balance it again. Now, this is how everything is. I have just 2 carbon here, but here I have just 1 carbon. If you put, if you put 2 here, what you are trying to say is that you are making another carbon. And this is a blunder in chemistry, because this is not a compound at all. So you see why you cannot put this here, and why it is advisable that you apply them in form of molecular coefficient. So the fact that I want to balance carbon to be 2, and I put 2 here, means that I am now having 2 molecules of this, which means I am having another CO2. Remember I said when you put it here, you are not just affecting this, you are also affecting this. So that means I'm having another of that compound also. Are you getting the pictorial representation? So now, this is for carbon. That means I have 2 carbon and I have 2 carbon here, because I have 2 molecules, 2 moles of that compound. Like I said, let's come to hydrogen also. I have 1, 2, 3, 4. 4 moles of hydrogen. Here, I have just 2 moles of hydrogen. I said 2, I want to make it 4. It will be a blunder if I just clean these 2 and make it 4. There is no compound like that. So what do? I put it in form of coefficient. 2, I am looking for 4. How do I get 4? By multiplying it by 2. And this 2 means what? I have drawn another compound, another mole of water. So I have 2 moles of water in this place. So definitely my hydrogen, which is 1, 2, 3, 4, is already complete. But something has happened. I have added to the atom count of oxygen. So in this product, how many oxygen do I have? I have 1, 2, 3, 4, 5, 6. Can you see the visual representation helps you better? So I have 6 atoms of oxygen. But here I have just 2. So what do? I cannot just clean this and put 6. No, that would be wrong. In form of multiple, I have 3. So this means I'm having 3 moles of oxygen. And how is that done? That means I'm having 3 moles of this compound. Can we do the atom count of oxygen here? So we have 1, 2, 3, 4, 5, 6. 3 moles. And here I have what? 1, 2, 3, 4, 5, 6. Oxygen is what? Balanced. Do we get the picture representation of that? So this is the picture representation of balancing the compound. But before you can be able to do that, you must be able to draw the structures fully well. I want us to do something complicated before we go close for today. So we say, let's say we have Fe2O3 plus H2SO4 to give you Fe2SO4 Remember, we are going from simple to complex now. Plus H2O. Don't feel frightened. This is a very simple equation for us to balance. And how do we go about it? Now, I want to call your attention to something. I know this is looking quite complicated, but when you see a compound like this, do not fret. Because why? I'm very sure one of the reasons why you may have difficulty balancing this is because of this. You may be thinking, how do I do this? This 3, is it for everything? Is it for only when you are advanced? Then you understand that, oh, there is a way to go about this normally. But when you see a question like this, iron is on its own, this is on its own. We have sulfuric acid, SO4, as a radical. We have it here as a radical, but it's carrying a subscript. So what do we do? Next time when you see a question like this, represent SO4 to be X, so you don't have issues. How do I do that? So that means it makes it easy for us to balance. So I have what? Fe2O3 plus H2X, where X is SO4, to give me Fe2X3, because my X is carrying 3, right? Plus H2O. Now we have a simplified equation. How should we balance this again? Let's take our atom count. Iron, we have 2, right? Oxygen, we have 3. Hydrogen, we have 2. Our X, we have 1. Iron, we have 2 here. We have 3X, we have 2 hydrogen, then 1 oxygen. Okay? So let's start with iron. Iron is 2 here, right? Iron is 2 here. Then iron is 2 here, which means iron looks balanced, right? But oxygen is 3 here. Oxygen is 3 here, and in this place, we have our oxygen to be 1. We have our oxygen to be 1. And like I said, I told you that when you want to balance, you go for the smaller number to make it a multiple of the higher number. So if I'm having 3 here, what do? What I need to do is to come to the place where I have 1. I want to make it 3. So what do? I put 3 here. So oxygen automatically becomes 3. But it has affected hydrogen. Hydrogen is no longer 2. Hydrogen is now what? 2 times 3. That is 6. Hydrogen molecule in 3 places, which makes it 6. Excuse me. So now that we have 6 hydrogen, let's come back to this place. Oxygen is balanced, iron is balanced, but hydrogen is not balanced because I have 6 molecules of hydrogen here and I have just 2 molecules of hydrogen here. So how do I do that? The best way to do that is by making it multiple. I'm trying to make up to 6. What will I multiply by 2 that will make hydrogen 6? That is what? 3. So if I multiply this by 3, hydrogen is no longer 2, hydrogen becomes 6. So yay, hydrogen is balanced. Now let's come to our X. My X here is 1, but my X here is 3. Like I said, you do what? You come for the smaller number. But do you know that because of the 3 I placed here, it did not just affect hydrogen. X was also affected. So summarily, X is no more 1 here. X now becomes what? 3, because I have 3 moles of this compound. Now that my X is 3 here, what is also my X? My X is also 3. So iron is balanced, 2, 2. Oxygen is balanced, 3, 3. Hydrogen is balanced, 6, 6. And before we know it, our X is actually balanced, 3, 3. And remember, now that you have done this, please place your X back to what it used to be. So if I'm going to rewrite this, I'm going to put Fe2O3 plus 3H2, my X, SO4, to give me what? Fe2, my X, SO4, 3 plus 3H2O. Now, this is what? Balanced. Do we understand this? So, that is where we'll be ending this for today. I would have loved to solve more questions, but you can practice more questions and reach out to us or leave a comment. that is where we'll be ending for today. So please do well. Once again, this is Further Solutions Academy. Do well to share and subscribe to our YouTube channel. And you can reach us on +234 80 95990. You could give us a call, you could leave us a WhatsApp message, or you could even reach us via Telegram app. Any one of this is fine. When you have any challenges or you have any contribution or comment, you can reach us to this. Once again, this is Further Solution Academy. Thank you for watching.